Second part of 3-4, we talked yesterday about solving exponential equations. Now we'll solve logarithmic equations. Just like yesterday, you can set things whenever we have bases that are the same with exponentials. You can have, if bases are the same, then your exponents are going to be equal, or that's basically what you're trying to do in most cases. With your logarithmic equations, same rules apply. So if you have bases that are the same, you can solve from there with your of statement. In some cases like here, where the first set, you're going to want to turn these, if you only have one log, you want to turn it into an exponential. So if I have log base 2 of x minus 4 equals 3, I'm going to turn this into an exponential. So remember that 2 is my base. The 3 comes over with the 2. And then the whole of part, or in this case the x minus 4, will go to the other side. And then we just solve it just like a regular equation, just like I would. I need to do 2 to the third, which is going to be 8. So x minus 4, add 4 to both sides. 12 is equal to x. Just like we did yesterday, if you have something that, like on 13, that we need to remove or simplify first, like in this case with the 3. If there is a number in front, okay, we need to remove that number or simplify it. I guess would be the better term. So I'm going to divide both sides by 3. So I have the natural log of 2x is equal to 4. Now remember, and this is one of those that with the natural log, students tend to forget that really that's just the same thing as log base e of 2x. So we treat everything the same way. E is your base, so it's going to be e. The 4 comes over to the other side, the 2x goes to the other. So I have e to the 4th equals 2x. Now, for me, it's perfectly all right unless it tells you to round it to the nearest decimal. Whenever you divide by 2, I'm okay with you leaving this as x is equal to e to the 4th over 2. That's your exact answer. Okay? If it asks for a decimal or you to round it, then actually type in e to the 4th divided by 2. Fair enough? 4 is really no different as far as, you know, what we did on, or 14 rather, of what we did on 12. 2 is your base, 3 is your power, x plus 2 is over on the other side, and you go from there. In some cases, whenever you have, there's really two types. If you have 2 logs and you have nothing else, you can set those equal and take your of values and go from there. If you have 2 logs, like in this case that you have x, or log base 2 of x plus log base 2 of x minus 7 equal to 3. Okay, if you have a third term that is a constant, okay, you can't just set the 2 equal to each other and go from there. You're going to have to most likely condense them, okay, because they're already expanded. So if I am going to condense these two, and if it's plus, what am I going to do? How am I going to rewrite this? If I have log base 2 What am I going to do with the x and the x minus 7? Multiply them. Okay? So you can shortcut it. You can write it as x times x minus 7 equal to 3. If you want to go ahead, what you're going to have to do is take log base 2 and have x squared minus 7x equals 3. So I'm going to have 2 to the third power. Remember, here's my base. 3 comes over. The x squared minus 7x goes to the other side. I'm going to have to factor. I'm going to get two values. Okay? I'm going to get two values that will, in this case, be 0 equals x squared minus 7x minus 8. I need to factor that out and have x minus 8 and x plus 1. So my two values that I get are a positive 8 and a negative 1. Now, one of these will work, one of these will not. Okay? I can't have a negative in the of statement. So I can have a negative x, but I can't have a negative value. So I can't have log base 2 of negative 1, and I can't have log base 2 of negative 1 minus 7, okay, because that's going to give me a negative 8. So the negative 1's not going to work. The 8 will work, however, and we can go from there. Same way on 15, you have log of x plus log of x minus 3 equal to 1. So I'm going to have log of x squared minus 3x equal to 1. Remember, if there's no log listed, it's really log base 10. So 10's my base. 1 comes over. X squared minus 3x. 0 equals x squared minus 3x minus 10. Need to factor. X minus 5 and x plus 2. So x is equal to 5, x is equal to negative 2. Which one of these is not going to work? Negative 2. Again, this is what we talked about earlier. This is kind of like your exponents or exponentials yesterday. If you have common bases, then you set the of portion equal to one another. The reason why I like these is because they're the easiest of any of them, to be perfectly honest with you. You may have to combine. Okay, you may have to combine or condense. You may have to expand a little bit. That's okay. But for the most part, like in this case, if I have the natural log of x plus 2 minus the natural log of 4x plus 3 is equal to the natural log of 1 over x. If it is a subtraction, remember, I'm just going to have the natural log of x plus 2 over 4x plus 3 equal to the natural log of 1 over x. Since they're both log base e or the natural log, same thing, all I'm going to do is drop off the logarithm, and I'm going to have x plus 2 over 4x plus 3 equal to 1 over x. Now, if I have two fractions that are equal to each other, what am I going to do? What have you done before? Huh? cross multiply, right? Remember doing that? So x squared plus 2x equals 4x plus 3. Same rules apply. I'm going to move everything over to one side, and I am going to subtract 4x. And I'm going to have negative 2x, and I'm going to subtract the 3. Factor everything out and have x minus 3 and x plus 1. So x is 3 and x is negative 1. Which one is not going to work? If I plug it in, which one would give me a negative value inside my of statement? If I plug in a negative here, is that going to be a negative value? Yep. Boom. So 3 works because 1 over 3, 4 times 3 plus the 3, and you can even plug everything back in there to make sure that it works as far as, like if you think about it this way, if I would take that negative 1 and it would plug back into your middle. So 17, I have log of x minus 3. What am I going to do with the 7x minus 23 and the x plus 1? Since it's subtraction? Divide. So I have 7x minus 23 and x plus 1. Oop. I kind of... 7x minus 23. So if everything is equal, now there's not necessarily a problem here, but you have an x minus 3 on the left side, then you have a rational expression on the right side. Can I still cross multiply? Is the one on the left still a fraction or a rational expression? Yeah, why? It's really over 1. Okay, do everything the same way. So I'm going to take the x minus 3 and the x plus 1. I need to multiply them. Now, it's completely up to you as far as what you want to do. I'm going to go ahead and multiply them together and have x squared, minus 2x, and then minus 3 equal to 7x plus 23. I'm going to move the 7x plus 23 over to the other side.
Is it supposed to be minus 23?
Oh, it is minus 23. Thank you. I did not catch that above. So negative 9x, and then add the 23, so it's going to be a plus 20. Factor out what I have, so x minus 5 and x minus 4. So x is equal to 5 and x is equal to 4. Any of those not work? Or is everything good? In this case, you have two answers that work. Okay? 5 minus 3 is still positive. 5 times 7 minus 23 is still positive. 5 plus the 1 is positive. Same way whenever I go back through with the positive 4. Okay? There's not a negative in my of statement, so everything's going to work out just fine. Okay, there's no issues here.